Hello everybody, this is Read the Source, episode 17. Episode 17, React Redux. Along with us we have Dan Abramov.
This is me. Hi.
Hi Dan, thank you very much for joining us.
Thank you for having me.
And Patrick Stapleton. Hi Patrick. And myself, Stefanaki Cornell. And Dan, this is your call.
Yeah, so
surprise us.
we're going to discuss React Redux library, which is like a generic library for connecting React components to Redux store. So let me figure out how to share my screen here. Entire screen. Okay, is it working?
Yes, we can see your screen.
All right. So we're going to start with an example. Everybody's sick of this example. This is the to-do example. And this is example from official Redux repository. I can add to-dos here, and I can cross them out, and I can switch the visibility filter, which to-dos I'm looking at. So I'm going to show how we use React Redux in this example to connect React components and what React Redux actually does under the hood. So this is the source code for the to-dos example. You can find it in the Redux repo. And most of the components are what we call presentational components. And when we say presentational components, we mean that they only say how things look. For example, the footer has several filter links, and a link is a tag with graph that doesn't go anywhere and calls onClick handler. So this is all presentational part, how things look, but not how they behave. So with Redux, usually you have a Redux store, a single Redux store in your application that keeps all the state tree of your app. And you have reducer functions that manage how actions emitted from components affect the state of your application. But we're not going to focus on the reducers today. We're going to focus on what we call container components. So the first example of this container component that uses React Redux library is filter link. If you look at the demo that I have here, so you see in the footer we've got show all, active, or completed. And when I click them, the current visibility filter changes. So the way that works and the way we use React Redux to achieve that is that in Redux, changes are caused by actions. So what we want to do let me hide this for a moment. What we want to do when we click on the filter link is to dispatch an action with the type setVisibilityFilter. And here in the filter link component definition, this is a regular React component, but it uses the link component. That is the presentational component. It doesn't have any behavior. So what React Redux lets us do is take our behaviorless component that is only concerned with presentation and specify how it gets the data from the Redux store and how it behaves by specifying the props, in this case event handlers, and which actions they dispatch. So this is the main idea of the why you would use connect from React Redux, is to generate a container component called filter link that complements link component with some behavior and some data injected from the Redux store. In this case, what we want to inject is the active prop, because we want to show the current link as text and not as a link, because it's selected. So what we're doing is that we write a function called mapStateToProps, and React Redux will call this function. And this function accepts the first argument is the Redux store state, the whole state tree of your Redux store. And it also accepts the props you pass to the filter link component. Let's see where filter link component is used. it's used in the footer. So in my footer component, I say that this is the filter link for show all, this is the filter link for show active, and this is the filter link for show completed. So it's got this prop filter. And inside the filter link, we say that a link is considered active when the filter prop that we pass to it matches the current visibility filter taken from the Redux store state, that is the source of truth for all the state in the application. This is how we inject the data into the presentational components with React Redux. But we also want to inject the behavior. So to inject the behavior, we define another function that we call map dispatch the props. In Redux, when you want to make a change, to make something happen, what you do is you dispatch an action. And in this case, I've got a method call here, but really what happens is that it just dispatches a plain object with some properties, and you're going to get the idea. So this is just plain object. This function generates a plain object. And we want to say that when the link component calls its own click prop, we want to dispatch the set visibility filter action. So we kind of bind the behavior to the presentational component. And finally, we call connect. We specify these two functions we wrote, and we pass the component that we are connecting that doesn't have any behavior, in this case, the link. And connect from React Redux generates the filter link component, which is a regular React component. You just don't have to write it yourself. What it does is it subscribes to the Redux store. Every time the store state changes, it calls your functions, and it passes the result. It merges these props, so it's got active and on-click. It merges this in a single object, and it passes them as a prop, as props to the link component. So this is basically how React Redux is being used. And now I'm going to take a look at how it is actually written. Does this make sense so far? Do you have any questions?
Yes, so far there are no questions, and I wanted to mention that if any of our audience have any question, they can use the hashtag #ReadTheSource on Twitter, and we will pass the questions back to you.
All right, so let's take a look at React Redux library. It has just two experts. One of the experts is called provider, and we'll get to that later. It is not essential. This is not like the main thing to worry about, because the essential part is connect. And connect is a pretty complicated function. It generates a component, and it's very heavily optimized, so it might be a little bit unwieldy for React beginners. But I'm actually going to cover some advanced React optimizations that we do in this function, because we want connected components to be very fast. So we do a few extra tricks to do that. But first, let's take a look at the overall structure of what this code does. So this is the definition of the connect function. It accepts some your map state to props function, your map dispatch to props, and there are some other arguments that are not essential. These are the two. They are not actually required, but most of the time you want to specify those. And it returns. I'm going to skip here. It returns another function. So this is like the first tricky moment. Why do we have two function invocations? Why does a function return another function? Well, we do that because a lot of people like decorator syntax, even though it's not finalized yet, and Babel 6 does not support it officially, but a lot of people like it. And so we do this kind of extra trick with calling function two times. You see, this is the first invocation. We pass map state to props, map dispatch to props, and this is the second invocation where we call where we pass the actual component. So the reason it's done so is that we can, if we used ES7 decorators proposal, we could write it right in the link file. if it was not reusable, if this was the only use. Oh, okay, so link is a function that is not applicable here. But anyway, if link was a React class, which is fairly common for components, it would look like this, extends component. And so we'd be able to write the connect declaration this way. So it would return the function, and decorator would apply this function. And a lot of people like the syntax, which is why we support it. But it is not essential to understanding React Redux. It is just a nice thing some people want. But this is the reason why we return a function here instead of like accepting the component as the first argument. Anyway, so what does this function actually do? If you recall, what we want to get as the result is filter link, right? And if we look at how filter link is used, it is used as a regular React component. So what we want connect to return is a React component. This is why it declares a class that extends the component. But this is a very important point, and a lot of people miss that when they first view the source, is that it does not inherit from the component you pass it. So there is no inheritance here going on. The component it extends is just the component class from React that all components have to extend. But this is essential. We are returning a completely different component that does not extend what you pass. Instead, it uses what you pass inside its render function. This is equivalent, like if you don't know create element syntax, this is roughly equivalent to writing return wrapped component with some props. But what happens is that the class generated, the component generated by connect, it renders your component, but it passes the additional data to it that it gets from the Redux store. So this is the main purpose of connect. Therefore, connect needs access to the store. What it does in the constructor is it reads the store from props. And this is the easiest way to pass something in React as data. You just pass it as a prop to the component. However, it can get very tedious to pass a lot of props down. So this is the problem. Connect needs access to the store, but if we had to pass the store from the very top of the app, for example, here we declare a store in index.js. So we would have to pass it to the app, and we would then have to pass it to the footer, and then we'd have to pass it to the filter link by getting it as a prop, and so on. So we'd have to do a lot of this prop passing just to get store to every component, to every connected component. So this is very frustrating, and like it's a lot of boilerplate code. This is why we use an advanced feature of React that is called context. So context is not really something you want to use in your applications. I strongly advise against using it. But this is something that libraries like React Redux and React Router often do, because context lets you declare something like a global variable that is specific to a subtree of your component. What context lets us do is it lets us say that we want the whole application to have access to a single variable, in this case the store, and so that any component inside our app can read it from the context if it needs to. So this is the advanced API we use. And this is exactly where provider comes into picture. So a lot of people are asking, what does provider do? Like, is it some kind of part of Redux architecture? And it is not. Provider is not essential to Redux architecture. It's just a way to make store globally available to all the connected components below. So let's take a look at how context works. What provider does, apart from some legacy handling code, it uses a React method called getChildContext. Provider accepts store from its props. So you can see where I use provider, I pass the store as a prop to a provider. The provider remembers it at this store inside itself, and when React calls getChildContext, it says that the context for this tree includes the store. So this is similar to dependency injection. It just makes the store available to any child component that asks for it. And to declare that, so context is very opt-in API. It's kind of unstable, so you shouldn't use it in apps. And so React kind of asks you to jump through a lot of hoops to actually use it. So you have to explicitly define the child context types here at the bottom. We need to tell React that this component, in this case provider, puts something called store inside the context. Because if you don't do that, React won't even call your getChildContext function. So this is why we tell it that this component has store in its context. And connect, the component generated by connect, this class, it reads the store either from props, if you pass it explicitly, or from the context, which is the second argument to the constructor. And again, context is opt-in API. So in connect down below, we actually define context types, which is, this is child context types in provider. It says what context it passes down. And this is context types on connect, which says what it wants to grab from context. So this is on the receiving end. So if you're only familiar with props and React, context is like a wormhole between components, but you should not use it to pass data. It's only useful for dependency injection, and it's only useful if you're a library author, because in your app, it's best to pass everything by props. So this is how the store ends up in the connect component, even though we have not passed it explicitly. But what do we want to do with the store? So the primary purpose of connect is to call your map state to props function every time Redux store changes, so that, for example, when the visibility filter changes, it's going to call map state to props, passing the new state with the new visibility filter, and if the link is no longer active, the active prop passed through it will change. So it's essential that we subscribe to the store. And Redux store has a method called subscribe. So this is what happens when the component mounts. We use the component did mount hook that React calls. So when the component is in the DOM, we subscribe to the store. Let me find this method. Okay, so it's declared here. We're calling this.store.subscribe, and we pass this.handleChange. So anytime the store state changes, we want handleChange to be called. The storeSubscribe method returns the function that will unsubscribe this handler. So we save it in a field. And later, when React calls let me find it, component will unmount, we want to clean up the subscription because it is no longer relevant. We want to stop, we don't want to receive events anymore. So we call this unsubscribe function that we received from store subscribe call, and we just get rid of it. So what does handleChange actually do? Because this is like the most commonly called function. Anytime any of the store state changes, every connected component will have its handleChange function called. So it better be optimized, right? Because you don't want to like calculate a lot of things in such a tight spot. So let's look at handleChange. First of all, and this is a tricky moment, it checks whether we have unsubscribed already and nullified the unsubscribe function. Because Redux actually doesn't guarantee that handle change won't be called after you called unsubscribe, which is kind of weird, right? Because we unsubscribe, and this must mean that handle change is no longer called. But this is not the case when you dispatch from inside a subscriber. So what Redux actually guarantees is only that after that changes to subscriptions, such as subscribe and unsubscribe calls, will only take effect on the next dispatch. So this is why we have this kind of check here. Now, in the handle change function, what we want to do is we want to take the next state of the store, the whole state tree. In this case, you can call getState method on the store to do that. And note that in Redux we guarantee immutability. At least we actively expect people to not mutate data in the stores and to keep their reducers pure. So because we have this assumption, we can actually use a reference check here. We keep the current, the last rendered state in the React local component state. So this is something that gets tricky. So pay attention to this. We're getting the global state from the Redux store, but we're keeping the last rendered copy in the React component state. This is just the abstraction that React provides us, so that we can compare them. And if the store state has the same reference, then we don't need to care about, it means nothing changed, right? So in this case, we can just skip it. But if something changed in the store, we're going to use React setState method with the new store state that we just retrieved. But this is not the only comparison here. So when we set the state, React is going to run random method again.
Sorry.
Yep.
Sorry for interrupting. I have a question.
Yep.
Regarding to the condition that you're checking here. What is the use case actually when the previous store state is equal to the store state?
Yeah, this is a good question. I'm actually, I think I'm not sure myself, because I just realized that this might not be, we might not need this check, because if the subscriber fires it, I think the only way this could happen if there is an action that nobody handles, or if there, yeah, I think this might be the only case if there is an action that nobody handles. So this is probably not a very relevant check, and we'll have more sophisticated checks later. But you're right, it's not relevant here, because this is comparing just the root state, right? It's just the state tree itself. But what we actually want to compare is the parts that you select from it. So this is going to happen further. Does it answer your question?
Yes.
Okay. So
thank you.
Good catch. Let's look at the random method. So in its most naive version, and I'm just going to write it to give you an idea of how React Redux started. In the most naive version, we'll probably do something like const props equals map state to props with current state, map dispatch to props with the dispatch function from the store, and we just return the component that you passed with its props. So this is like the 0.0.1 of React Redux. But this is terribly inefficient, because maybe map state to props returned the object with the same values, where every value is referentially equal. And in Redux, this means that, like, if the props are shallowly equal, they are equal. You don't need to waste React rendering in this case. So this is inefficient. You want to prevent rendering if these things are shallowly equal to their previous values. So what you might want to do in this case, you might have read that you need to implement should component update hook in React to make this performant. So again, in our naive first implementation, we implemented should component update. It receives the previous props and the previous state, and it looks something like if the previous props equals to the current props, and if the result of calling map state to props is equal, so you get the idea. We check that these values are shallowly equal to their previous values, we can opt out of rendering. So this is what we try to do first. At the second try. But we discovered that this poses some problems because calling map state to props from inside should component update, we need to pass the Redux store state. In this case, we keep it in this state, that store state, and the current props. But the problem is that if you nest components, nest connected components, and some of them are connected to the store and pass props down to other connected components as props, what you may end up with is a situation where the props that are currently rendered are not corresponding to the current state of the Redux store. And this happens because in React, rendering is asynchronous. So in React, rendering can be batched. If you're calling setState several times while you're in event handler, React will batch these calls. And in general, React moves toward a more asynchronous model. So you should not rely on things updating immediately. But Redux store does update immediately, because when you dispatch an action, the register is called, the state is updated, bam, like the new value is there. So we ended up with some stale props issues that were very tricky to debug and caused like really painful bugs in components, in applications with nested connected components. So we stopped doing that. And the solution we came to, which may look somewhat strange, but what we do now is we call the mapStateToProps function inside render method. This is not immediately obvious, but there is this update state props if needed, and if we jump to its definition, is going to call compute state props, and this is actually going to call your mapStateToProps function. So what happens is that we delay calling these functions until the very last moment, until the rendering, so that they always get the up-to-date props that the component is going to be rendered with. Let me find it. Okay, so but how do we implement efficient updates if we don't use the React should component update hook? Well, it turns out that React has another mechanism for optimizing updates, although it's not as widely documented or explained. In React, there is a notion of elements. So what you return from the render method when you write something like return wrapped component with some calculated props. So when you do that, it triggers to return React create element wrap component with its props. And in fact, React create element is a very simple function. It's a tiny wrapper with some conveniences and some checks, but it really returns an object of the shape, like it has a type and the props. So this is just an object factory, and these objects that describe what you want to see as a child component, these descriptions are called elements in React. So it turns out that you can actually cache the element. If you return an element that is referentially equal to the previous element that render function returns, React is going to bail out of reconciliation. It's going to figure out, okay, the element is referentially equal, so it means nothing could have changed, so I don't need to re-render this. So you probably don't need it in your app until you're having like a giant list view or other kinds of performance stress situations. But this is handy to know that you can cache, like in this case, render method, it's supposed to be pure, but I'm actually memoizing the last rendered element. And if I know that the props have stayed the same, I'm just going to return it again. And I just cache it on the component instance. So this is another curious example of how like classes do solve some problems in a way, because sometimes having instances makes it easier to memoize things, to do some kind of dirty performance hacks, just to get the speed you want from the library. Now I'm going to take a look at how we actually calculate the props we pass.
I have a
Yeah,
before
sure.
you continue, I have a question. Does this solution have I don't know, what's the big difference between the initial and the second solution in the from the performance point of view? By caching the elements, do you introduce higher memory usage, or I don't know?
No. So the only difference, as far as I know, between using should component update and caching elements is that the only reason we do that is because we care very much about calling your functions, your map state or props function, with the props that are going to be rendered. And we don't actually know the exact props until the render function is called. So this is a very tricky edge case. You probably are not going to bump it in your app. But as I said, we had issues with nested connected components and this API that lets you use props to calculate the props to pass down. So we have to delay calling these functions so that we call them with the up-to-date props only. But yeah, this is very specific to this particular API because we really want to give you these own props here so that you can compare it against the state. And this is why we kind of have to jump through the hoops. In fact, if I'm completely honest, we actually do have a should component update function. So yeah, it's here. So our should component, usually people compare stuff in should component update, but as I said, we can't compare the props because we can't calculate them yet because we don't know the current values of the props that are going to be rendered. So we just have some flags that we set from handle change, and component will receive props that are just Boolean flags, and this is just a quick way to bail out if we know that nothing has changed, so we don't even need to calculate anything. So we actually mix both techniques in one place. But of course, the only reason we've been able to do this is because we wrote a bunch of tests that test whether certain methods are called certain amount of times. And so this is what makes this kind of refactorings easy. But if you don't have good test coverage, you should just use should component update because this is like the recommended way. Does that answer your question?
Yes.
Okay. So yeah, and you can see this when the component itself receives props. For example, when in the footer we render filter link with a prop filter show all. But what if this was some dynamic expression like this? Say footer open, and in this case maybe different values, for example. So in this case, React calls component will receive props method. And what we do here is we compare shallowly the next props with the current props. We make the assumption that your props do not have deep mutations because this is like in line with React model, with the Redux model. And if they have, like, if something happens, we're just going to set this flag so that should component update doesn't bail out, and that we get in the render method, and then we calculate the result props and see if they changed. So we're in the render method, and this is like the meat of the whole thing. We grab the rendered element from this in case we ever want to return it as is, and we grab whether the store state reference changed, and we're talking about the in the handle change, it just checks the root state object. So it's not very interesting. Usually it will change and have own props changed, which is determined by component will receive props. So anytime new props come up, we end up in render, and we know that these have changed. And next, we reset these fields, of course, because they are only relevant for a single render. So we reset, and now we're going to calculate whether we actually need to render. So we assume in the beginning that both state props and dispatch props need updating. So what do we call state props and dispatch props? It's very easy to get lost in this stuff because, we state and props, we're gonna mix them all the time. And so what we actually mean here is, when I say state props, I mean the thing that is returned from this method. So it says map state to props. These are the props that are calculated from the state. This is why we call them state props. Similarly, in this function, we receive dispatch, and we return the props that are based on dispatch, that are calculated from the dispatch function, from having it available around so we can call it. So we call this object the dispatch props. And our task is to determine whether this thing have changed and whether this thing have changed, and whether it is worth re-rendering the child component because either of them has changed. So we start with the assumption that everything has changed. But then we're going to kind of try to avoid reconciliation. So pure is just a flag, most of the people don't know it exists, and I'm not going to advertise it much, but this is just, it is passed in the options as the last argument, which is very ugly to pass if you use this API, and it's intentional because you only want to use it if you have mutable data, or if you use a library like FactRouter that has some problems with strict should component update. For example, links active state won't update if somewhere in the middle there is a pure component. So as a last resort, we let people pass pure false if they want to, and this will kill any optimization. So we will out of any optimization if pure is false, but most of the time it will be true. So what we say is that if we have a rendered element, like if we have something cached that we can return, it is worth investigating whether we should return the cached element. In this case, should we update the state props? It depends. For example, if the store state has not changed, we shouldn't. But even if it has changed, wait. Okay. So yeah, this is the interesting part. So if the store state changed, we always need to update the state props, right? Because they depend on the state. I do a calculation that depends on state. If the state changes, I want to recalculate that. But, however, we also want to recalculate the state props if the own props changed, and the state props depend on own props. So what does that mean? Let me give you an example. Here, we accept two arguments, state and own props. And we calculate what we call state props based on both of them. So if the props that the filter link component itself receives change, we need to update this. However, there are also cases when map state to props doesn't care about the own props of the component, when this calculation depends only on the state. As an example of such component, we can look at visible to-do list, which depends on the current state of the Redux store, and it calculates the visible to-dos from it, but visible to-do list doesn't accept any props, so it doesn't matter, right? So in this case, it would be silly to recalculate this function if visible to-do list props change, right? So this is why what is this do state props depend on own props? How do we calculate this? Let's see the definition. It checks the length of the function that you pass through. So if the length is 1, in this case, if the function looks like this, if the length is 1, then we know that it does not depend on the props, and we can skip this recomputation when the props change. But if the length is anything else, for example, 2, or 0, if the function is wrapped into another function that returns it or something like that, then we need to be careful. So this is why we have this do state props depend on all props. And we also have do dispatch props depend on all props. In fact, this optimization is much more essential, because if you look at map dispatch to props, it allocates functions. So when we bind action creators, we allocate functions, and this is costly, and it's especially costly if you do this in loop, or in a tight spot, or for 1,000 components. So what you don't want to do is end up in a situation where every time some prop changes, some random prop, you are going to regenerate this object again and again with all these functions. So in most cases, map dispatch to props will not depend on own props. And again, this gives us a quick chance to just do this once, to calculate this when the component is created, and to never ever update this value again, because we know that it only depends on dispatch, and dispatch is available right in the beginning because it is a method on the store, so we can just calculate this once. But in some cases, of course, we cannot rely on it, like in case of filter link that depends on all props. So we ask that in advance. And similarly, should we update dispatch props? Yes, if all props change, and unfortunately, the props that we pass down depend on all props. Does it make sense so far?
Yep.
Okay.
Yeah, so it seems like you're doing a ton of work to ensure.
Yeah, we really don't want to waste, this was the point of these bindings, because if you didn't have these bindings, you could have written a trivial implementation of Connect that just returns a component that subscribes to the store and passes the current state down and calls force update when the store state changes. And this is actually how I implement, how I kind of show container components in my Redux ACFET course. So I just use force update there because it's easier conceptually. But we want to do a ton of work in the library to avoid wasting your application time. So yeah, this is a big focus of this library. You have a good performance. You're lucky that this is abstracted away, right? You don't have to worry about it. So by this point, we know that we need to check whether these props have changed, the state props and dispatch props, but we don't actually know whether they have changed. So we're going to assume in the beginning that they have not changed. But if we should update them, if we just determine that it's worth checking, we're going to call a special function called update state props if needed, and a similar function called update dispatch props if needed. And if we jump into their definitions, they're going to call something called compute state props and compute dispatch props, which we'll get to in a second. But they're also going to minimize the last result. And in this case, if the value is shallowly equal, like if you return the exact same things, for example, you return active false again. So on props may have changed, or state might have changed, but if you return active false 2 times, we don't want to render again, right? Because these things are equal. There is no point even going further. So we want to save the previous state props, and we want to check shallow equality. And again, we say that if they are shallowly equal, we don't even want to save a reference to this, because the last reference is good enough, right? It's memoization again. We're just going to keep it until it changes, in which case we're going to reassign it and return true. So if we return true, then it's going to see whether any of the props have changed, including state props, dispatch props, and actual own props of the component, like because we pass them down too. And if this is the case, it's going to update merge props by just merging them, well, like extend and underscore object assign is the same way. And only if the merged props have changed and we don't have the rendered element, or we don't have the rendered element, only in this case we're going to update our rendered element and return it. So the final part I have not covered is what is this compute state props. And this function is defined here. It takes the current state of the store at the moment of its invocation. So again, this is important. We have the props that are going to be rendered in the render method, that are guaranteed to be the props that we receive, and we have the current state that is guaranteed to be state at the time of render. And now, only if we know that we need to pass props, we will pass them. And we check that what you return is plain object, but we just return whatever you return. And compute dispatch props is very similar. It grabs dispatch from the store, and it passes it to your function. It makes sure that you return a plain object, and it returns them. And compute merge props, it just calls merge props. It is configurable, but the default implementation looks like just, merging them together, just like object assign empty object, then this, and this. So this is pretty much what happens here. I can recap it. The connect function creates a special component that takes care of subscribing to the Redux tool. It receives either via props, but it's painful to pass, or via context. In this case, you have to use provider in the root of your application. It subscribes to the store as soon as the component is mounted, because on the server you don't want to subscribe, so you don't leak these subscriptions. It subscribes to the store, and in its change handler, it uses setState to schedule a rendering. So this is something that is not immediately obvious, but the purpose of setState here is to schedule the rendering. If there are several setState calls within one event handler, they're going to be batched by React. So this is why we don't do anything to render right now. We just schedule the rendering with setState and this current store state. And when React figures out that, okay, it's time to actually render, we try very hard to avoid recalculating anything. If we recalculate it, we try very hard to kind of bail out if your if the objects you returned are shallowly equal. But if we failed on all of these fronts, we're going to update the merge props, and in this case, we're going to return a new element. But in all other cases, we're going to return the cached one to avoid reconciliation. And the final unobvious part here is with ref. So in React 14, we have functional components, and they don't allow us to put refs on them. So I know some people check for component for whether a class inherits via component to tell whether it's a class or function. But we just decided that refs is an antipattern, and most of the time you don't need them. And if you do need them, think twice before you use them, especially refs to the instances. So make this opt-in argument, and users can specify it in the options. So by default, it's false. And if you specify with ref, then it's going to be available as a ref. But otherwise, we're just going to pass to create an element without the ref. And we kind of save one allocation here because we pass merged props without creating a copy here. But yeah, this is pretty much it.
Thank you very much, Dan. We have two questions.
Okay.
So, just a second, please. First is from Sachin. Can you explain rationale behind separating container and presentational components? For him,
Mm-hmm.
seems like there is an extra files or code.
Yeah, so this is not required. Like you can always, for example, if I've got there is a technical and more maintenance point of view, kind of different reasons for the separation. So the technical reason is that it's hard to write performance code to subscribe to the store correctly by yourself. So we just provide you a helper to do that, right? So if you don't want to separate them by files, you can totally like call this filter link, and you can say that filter link equals connect these functions filter link. So everything is in a single file. You can declare these map state to props in the same file and just kind of use them. And the components that use filter link are not even aware that it's actually declared that you use connect, like it's implementation detail. So this is the technical reason. And for small components, for example, I've got add to do component. This is actually what we do here. So add to do, this is the input box, and it's very simple. And it's not like it's very reusable, so it doesn't make sense to kind of separate presentation from the behavior. So it just accepts, dispatches a prop. It does. It has both presentation and it uses dispatch itself. But it still uses connect to just efficiently subscribe to this. Oh, it just uses connect to inject dispatch. But you could write map state to props here, and it would receive these as props. So this is a technical reason. But a more like from the maintenance point of view, the point is that your components are more usable. And for example, I've got to-do list here that is presentational component that just renders to-dos that are not bound to Redux store. And now it's easy for me to create separate many container components, for example, visible to-do list. Like I can create like pending to-do list, something else to-do list that behaves in a different way. And this is especially great for like applications with different kinds of entities fetched from the server. For example, I can have a presentational friend list component, and then I can reuse it with different container components like followed friend list, blocked friend list, like follower friend list, I don't know, all different kind of, that fetch data differently, that use different data from Redux store, that may have different checks on the actions or dispatch different actions depending on conditions, but they have different logic. So this is when separating them by files gets beneficial. But definitely, if you don't feel like it's a good pattern for you, just don't use it. This is not essential to Redux. This is just a pattern we found helpful in large applications.
Thank you. And the second question is from Mike, and he asks, which plugins of Redux do you currently use or excited about?
Sorry, which plugins for what?
For Redux.
I don't really use anything because I'm not developing any apps right now with Redux. If by plugins they mean like middleware or enhancers, of course I'm excited about Redux DevTools because I think it's pretty awesome to like time travel and reproduce states. I like Redux Saga, which is fairly recently. It became popular very recently. It's a middleware for kind of getting rid of asynchronous action creators and instead describing your app with sagas, which is closer to event sourcing pattern where your components emit events, like what happened, and sagas are like workers that take these events and turn them into streams of actions with asynchronous control flow. So this is something, this is a pattern I find interesting. But yeah, there's something interesting new every day, so it's hard to pick.
Okay, I think that you can stop sharing your screen.
All right.
So we can see, and there is another question from my side. What is the best type of application that you would recommend to use React Redux with?
Yeah, so it doesn't make sense to use Redux for applications that don't have a lot of client-side state. So React Redux is useful when in Redux itself when you have a lot of client-side mutations that are fairly complex. For example, like a post editor or like um, I don't know, many kinds of enterprise apps or business apps where you have some kind of constructors, forms, when you create things inside other things, and they are all local. They are not. They are persisted to the server only when you press a button, or if it's like a game, anything with complex local state, I think can benefit from Redux. And Redux does not have a very strong story about data fetching. So if you have very complicated data dependencies, it's best to either use Relay, which handles this for you in React ecosystem with GraphQL, or maybe some layer on top of Redux, because I know some people are currently writing higher level libraries on top of Redux that would deal with data fetching, normalization, kind of easier handling of these concerns. So Redux is pretty low level. It's don't expect too much from it. It's just a way to kind of get on top of your local state mutations and not feel overwhelmed.
Thank you. Patrick, do you have any question?
No, it was great. You explained everything pretty well. It was pretty simple. It really shows that you were doing like a ton of work and optimizations with it, so that's great. Sure.
Thank you.
It was awesome. So thank you very much, everybody. Thank you, Dan. Thank you, Patrick. Thank you to all the viewers. Great questions. Yeah, that's it. Have a great day, everybody.
Bye-bye.
Bye.